कहाँ तक कर लिया था हमने? एवरेज वेलोसिटी आ गया था ना. Average velocity was done and average velocity was done. हाँ, डाउट्स के लिए मैं अलग से एक सेशन रखता हूँ, इसमें आप अपने डाउट्स क्लियर कर लेना. आई होप लेवल 1 में किसी को डाउट नहीं आया. लेवल 2 में डाउट आना चाहिए. अभी आ रही है आवाज ठीक से? हाँ करते हैं शिवन, अभी करेंगे ना. I'll keep a session separately for doubts. लेवल 2 में बहुत सारे डाउट्स होने चाहिए. Okay, so the next is number 7. Number 6. Average speed. Now this is not very interesting, and in a way you have already done it before. 6th year. So average speed का जो definition है 7 है. 6 है कि 7 है मुझे याद नहीं. ओके ठीक है कोई फर्क नहीं पड़ता. So the definition of average speed, I mean there is so speed is such an uninteresting, average speed is such an uninteresting object that we don't really have a symbol for it. So average speed you can simply write as distance upon time. Right? This is a scalar object, and the units of this scalar object is meters per second length over time. So I will not discuss about average. I will. This is it. Average speed is distance upon time. That's it. The only place where it sort of becomes interesting is when the definition of average speed begins to coincide with the definition of average velocity. Okay. So average speed becomes equal to magnitude of the average velocity when what? When will average speed become equal to the magnitude of average velocity? Good. Distance is equal to displacement. Distance is equal to displacement will happen when motion is in a straight line, unidirectional. So this is the only place where we can actually talk about speed. Otherwise, we don't talk about it. It it does not convey a lot of information. Okay, so this is it. This is all about average speed. अभी शुजोब तो क्या पूछ रहा है मुझे नहीं समझ में आ रहा. सेम डायरेक्शन का क्या मतलब होता है भाई? एक गाड़ी अगर सीधी रोड पे चल रही है तो एवरेज स्पीड उसकी एवरेज वेलोसिटी के मैग्नीट्यूड के बराबर होगी. खत्म. आगे बढ़ रहा हूं मैं. चेंजिंग द स्लाइड. The next term that we are going to discuss and agree on is called average acceleration. Okay, now average acceleration is sorry, उल्टा हो गया. Sorry, एक और बचा हुआ है. Eighth, we are going to talk about instantaneous so without the definition of instantaneous velocity, we really can't talk about acceleration. Okay, so what is instantaneous velocity and how is it different from average velocity? Right? Velocity at a particular instance, at a particular moment in time is instantaneous velocity. Yeah. So there was this, I remember there was this joke about the comparison of instantaneous velocity and average velocity. So there is a person who is driving a car, and we are talking about some place where the police have this device called a speed gun. So what the police do is that they stand next to a highway, okay, and they have this device called the speed gun. And basically for every car or every vehicle that passes that point on the highway, the speed gun will actually measure the speed of the car. So they're doing this to track people who are going above the speed limit, and if they are going above the speed limit, then the police is supposed to catch that person and exert a fine or whatever activity, whatever thing has to be done. So this person is driving a car, and the policeman pulls this guy up and says that, Mister, you were driving too fast, right? And this guy says, no, I was not. So the police guy says that, look, the speed limit that we have here is 80 kilometers per hour, but you were driving at 100 kilometers per hour. And the guy refuses. नहीं ऐसा हो ही नहीं सकता. तो पुलिस वाला बोलता है कि I have actually recorded this in the speed gun. I have this recorded value, I have this recorded reading of the speed gun showing 100 kilometers per hour. And then the guy says that, look, I have been traveling for 50 kilometers now. Okay. I am 50 kilometers away from my origin. I am 50 kilometers away from where I started. And I have been driving for 1 hour now. Therefore, my speed cannot be greater than, or my speed is equal to 50 kilometers divided by 1 hour. That is 50 kilometers per hour. You understand what is happening? The policeman had measured the velocity of the person of the car at a particular moment in time. That is the argument of the policeman, that you are driving at 100 kilometers per hour. And the argument of that man is that no, look, अगर मैं 100 kilometers per hour पे ड्राइव कर रहा होता तो 50 kilometers की दूरी तो मैंने आधे घंटे में तय कर ली होती, लेकिन 50 kilometers की दूरी मैंने 1 घंटे में तय करी है. Therefore, you can look at my GPS data and you can see that I have covered 50 kilometers in 1 hour. Therefore, my speed is or cannot be greater than 50 kilometers per hour. Right? Of course, the discrepancy is because these two people are talking about two different things. One is talking about the average velocity, where the person is talking about the total displacement that he has had divided by the total time that total displacement has taken place over, whereas the other person, the policeman, is talking about the velocity at that moment in time. Right? Now we need to be very clear about what do we mean by the velocity at that moment in time. Okay. In fact, is there a definition for a particular moment in time? So I'll show you what is the meaning of instantaneous velocity. And by the way, whenever I talk about velocity from now on, भाई ड्राइवर के पास स्पीडोमीटर है या नहीं है उससे कोई मतलब नहीं. ड्राइवर का आर्गुमेंट ही दूसरे बेसिस पे है. So I'll tell you the meaning of instantaneous velocity. Okay, and this is the thing that we are going to use for velocity. So I'm going to basically drop the word instantaneous. And whenever we talk about velocity, whenever I say velocity or whenever you say velocity, it will be understood that we are talking about the instantaneous velocity. Right? So if we want to talk about the average velocity, we'll have to actually specify. नहीं, मैं average velocity की बात कर रहा हूँ, और अगर मैं सिर्फ velocity word use करूँगा, so it is understood that we are talking about instantaneous velocity. Okay, so as seen from above, this is the path followed by a particle, right? So we are like gods looking from above, and there is a particle, and the particle is following this path that I have drawn. So at some moment in time, okay, I don't know what that moment in time is. At some moment in time, the position vector of the particle is here. And I will call this the position vector of the particle at time t. Okay. Now, before we move ahead, I just want to show you, I just want to tell you what is the meaning of position vector of the particle at time t. Right? इसका मतलब क्या है ये मैं बता देता हूँ. So the position vector of the particle bracket में अगर t लिखा है, इसका मतलब है that I am talking about the position vector of the particle, which remember is what? It is a vector drawn from the origin to the location of the particle. But अगर मैंने bracket में t लिख दिया आगे, then this is the position vector of the particle as a function of time. This is the position vector of the particle as a function of time. इसका क्या मतलब होता है? Function word कहाँ से आ गया? फंक्शन वर्ड हमने कहाँ देखा है? y is equal to a function of x. इसका क्या मतलब होता है? इसका मतलब बताने के लिए मैंने अलजेब्रा का फर्स्ट प्रिंसिपल इन्वोक किया। मैंने बोला था कि अगर एक नंबर अननोन है तो उसको हम x अस्यूम करते हैं, लेकिन अगर कोई अलजेब्रिक स्ट्रक्चर ऑफ x अननोन है तो उसको हम fx अस्यूम करते हैं, राइट? तो यहाँ पे fx का मतलब होता है any and all functions of x. So fx can be x square plus x plus 1. fx can be sine of x plus x square. fx can be ln of tan of x cube, right? We have seen so many functions in calculus. So fx is an unknown function involving the variable x. Okay? तो ये फंक्शन वर्ड यहां कैसे आ गया? तो ये जो पोजीशन वेक्टर के बाद मैंने ब्रैकेट में t लिख दिया, इसका मतलब कि आई एम टॉकिंग अबाउट पोजीशन वेक्टर एज ए फंक्शन ऑफ टाइम. This means that this position vector is a function of time. इसका मतलब the position vector is an expression, is an algebraic vector expression involving the variable time, right? And I'll show you a couple of examples. So the position vector as a function of time may be something like t square I cap plus t j cap plus 2t k cap, right? So this is meters, okay, or whatever unit of distance we will choose. I have chosen meters. अब इसका क्या मतलब है? तो हम यहाँ पे हाँ, always it will be a function of time. हाँ, always it will be. तो हम यहाँ पे the point is expressed in time नहीं यार, सुनो मैं क्या बोल रहा हूँ पहले. First listen, then type. Listen to what I'm saying. R bracket t, R vector bracket t का मतलब होता है that I am talking about the position vector as a function of time. And an example of position vector as a function of time is what I have written here. It is a vector quantity, and that is obvious because I have written it in terms of ijk, and it is involving a variable t, which is time. So now I can ask you, what is the position vector of the particle at time t is equal to 0, right? And all you have to do is put in the value of t into the expression, and you will get the position vector at time t is equal to 0. So the position vector of the particle at time t is equal to 0 is 0. Right? That means that time t is equal to 0 पे particle origin पे था. What is the position vector of the particle at time t is equal to 1 second? Right? So the position vector of the particle is I cap plus j cap plus 2k cap meters. Okay? इसका मतलब ये हुआ कि अगर हम विजुलाइज करने की कोशिश करेंगे तो ये पार्टिकल जब मैंने स्टॉपवॉच को स्टार्ट किया तब ओरिजिन पे था, और जब मेरे स्टॉपवॉच की रीडिंग 1 सेकंड हो गई तो ये पार्टिकल का लोकेशन इज एट द कोऑर्डिनेट्स ऑफ 1, 1, 2. ओके, राइट? I can also ask what is the position vector at time t is equal to 100. And you can answer this because आपको t का value 100 लिखना है. I can also ask what is the position vector of the particle at t is equal to -5 seconds. आपको t को -5 लिखना है. Right? T is equal to -5 का मतलब क्या हुआ? I am asking about the position vector of the particle 5 seconds before I started the stopwatch. Okay, remember we had this discussion last time that a certain moment in time can be designated as a positive number or a negative number or zero, but an interval of time must always be positive, right? So what is R bracket T? It is a position vector as a function of time. Okay? It will be something, it will look something like this. It will look something like this. Another example of a position vector as a function of time may be something like sine pi t I cap plus cosine pi p j cap, right? This tells me that the x coordinate of the particle as a function of time is sine pi t and the y coordinate of the particle as a function of time is cosine pi t. Don't worry about the complexity of the function, right? What you have to understand is that this position vector as a function of time will simply be some expression involving time multiplied by I cap plus some other function of time multiplied by j cap plus some other function of time multiplied by k cap. So I can write position vector as a function of time as ft. F of t. What is f of t? Some function of time I cap plus another function of time j cap plus another function of time k cap. You remember when we discussed functions, I told you that अगर f of x एक फंक्शन है और एक और फंक्शन आ गया तो उसको हम g of x लेके चलते हैं, एक और आ गया तो h of x लेके चलते हैं. यहाँ पे ये तीनों चीजें टाइम के फंक्शन है, इसलिए f of t, g of t और h of t लिखा हुआ है. Right? I hope this is clear now. What is the meaning of position vector as a function of time? So this tells me, what does it tell me? Tells me the exact location of the particle at all moments of time. Right? In fact, the goal of physics before the advent of modern physics, the goal of physics was to figure out the position vector of each and every particle that makes up the universe. If you have a knowledge of the position vector of each and every particle of the universe as a function of time, then essentially you know everything about the universe. You can put in a value of time t is equal to 0 and find out what was the state of the universe when your stopwatch started. You can put in the value of time t as negative to find out the state of the universe before your stopwatch started, and you can put in any value of positive time to find out what will be the state of the universe at any time in the future, right? Okay. So this is the position vector as a function of time. We go back here and the particle is following the path along the green line, and at some point of time on my stopwatch, the location of the particle is here, and therefore the position vector of the particle is r at some moment in time t. Now what do I need to do? Okay, now what do I need to do? So the motion that we want to study, I told you, if you remember in the last class, that the average velocity and the average acceleration, they are measuring macroscopic, or they are looking at the motion from a macroscopic point of view. This means that they are not interested in the details of the motion. They are only interested in when the motion started and when the motion finished. So their description of motion is based only on the knowledge of the initial and final points. But the instantaneous velocity and the instantaneous acceleration that we'll study later on are interested in the details of motion, right? They are interested in everything that happened, every little thing that happened. Nothing can escape instantaneous velocity and instantaneous acceleration. They must describe the motion in totality, okay? So therefore, what we do is we seek out the help of calculus in describing time, right? Now we know, we have all looked at a stopwatch, and we know that when you start a stopwatch, time begins, or the calculation of time or the reading of time begins to move forward. Okay. And if you are studying the motion of a particle, then the way to study the motion of a particle is to look at the position of the particle and then simultaneously look at your stopwatch and then measure this reading. After all, if you want to measure the speed of a particle, what do? अब आपके सामने एक सीधी रोड है, आप जहां खड़े हो, और वहां पे एक कार है, और पूरे रोड पे मार्कर्स लगे हुए हैं 1 मीटर, 2 मीटर, 3 मीटर एंड सो ऑन. जब आप स्टॉपवॉच स्टार्ट करते हो तो कार स्टार्ट होती है, और आप केवल स्टॉपवॉच देखते हो, 1 सेकेंड हुआ, कौन से मार्कर पे कार पहुंची? अच्छा 2 मीटर पे. फिर 2 सेकेंड हुआ, कौन से मार्कर पे कार पहुंची? अच्छा 4 मीटर पे. 3 सेकेंड हुआ, कौन से मार्कर पे कार पहुंची? अच्छा 6 मीटर पे. इसका मतलब कि कार की वेलोसिटी 2 मीटर पर सेकेंड है. हर सेकेंड में कार 2 मीटर आगे बढ़ जा रही है. Therefore, the speed of the car is 2 meters per second, right? So basically, the measurement of velocity depends on the measurement of time and position simultaneously, right? Okay. Now we want to describe the motion in the minutest detail that is possible. Therefore, to describe this instantaneous velocity, if I have chosen the position of the particle at time t, then the next moment in time that I should look at the particle should be when. Understand my question? If I am trying to describe the motion in its minutest detail, and I have just after t का क्या मतलब होता है? I have looked at the motion at time t, then I should look at the motion again at what time? No, it cannot be t plus 1. वो 1 सेकेंड में तो दुनिया पलट जाएगी. It should be, so this is where we take the help of calculus, right? What is the lowest, what is the smallest possible interval of time? The smallest possible interval of time is dt. right? So you can imagine nature as having a stopwatch, and the tick of the stopwatch is this dt, right? So there is a moment in time right now and there is dt afterwards. बीच में क्या हुआ ये हमें मालूम नहीं है, लेकिन हम बोलेंगे that the position vector of the particle after time dt is r at time t plus. Therefore, what is this vector? What is this vector? ये जो रेड वेक्टर मैंने ड्रॉ किया ये क्या है? This should be position vector at time t plus dt minus position vector at time t. Right? Please notice that there is nothing new I have introduced here except for the concept of position vector as a function of time. Right? अभी भी हम वही कर रहे हैं, RF, RI, लेकिन इस बार जो RF हम ले रहे हैं वो टाइम dt के बाद ले रहे हैं. तो ये जो मेरा डायग्राम है ये थोड़ा सा मिसलीडिंग है. Can you tell me why the diagram is, or what is wrong with this diagram? If I take an interval of time dt to measure the new position vector of the particle, very good, yes, very good, very good. If I measure the position vector of the particle after a time dt, then it is guaranteed that the red line and the green line will coincide with each other, and it is further guaranteed that they will both be straight lines, right? तो मैंने ये डायग्राम बनाने के लिए, बिकॉज मेरे को विजुलाइज आपको कराना था, इसलिए मैंने जो t plus dt वाला r लिया है वो थोड़ा सा ज्यादा टेढ़ा कर दिया है. Ideally, you remember why we took dx? What was the rationale of taking dx? The rationale of taking dx was that whatever type of curve we have, मैं उसका इतना छोटा part ले रहा हूँ कि it is guaranteed that that part will be a straight line. Similarly here, when I take or when I measure the new position vector at time t plus dt, then the displacement must be a straight line. देखो मैंने जो रेड एरो बनाया है वो डिस्प्लेसमेंट है ना, मैंने जो रेड एरो बनाया है वो डिस्प्लेसमेंट है, लेकिन जो ग्रीन लाइन है वो नीचे से कर्व होके जा रही है, ये नहीं पॉसिबल है. जो डिस्प्लेसमेंट होएगा वो रेड लाइन पे ही होएगा. मोशन ऑफ द पार्टिकल बिटवीन टाइम t and t plus dt will always look like a straight line. Okay? So, therefore, yes, every curve has a straight line as its smallest part. Yes, वही तो कैलकुलस का फंडा ही है. तो मतलब ये तो कैलकुलस का फाउंडेशन है. Okay, so the instantaneous velocity v is defined as the displacement divided by the interval of time. ये चीज पहले कहाँ देखी है? ये चीज पहले कहाँ देखी है? ये जो मैंने लिखा है ब्लैक में, ये पहले कहाँ देखा है भाई? याद है? कुछ याद आ रहा है? नहीं, ये डिफरेंशिएशन का डेफिनेशन है. If you remember dy by dx is equal to f of x plus dx minus f of x divided by dx. एक्चुअली ये नहीं होता था, नीचे x प्लस डी एक्स माइनस एक्स आता था, लेकिन x प्लस डी एक्स माइनस एक्स में x और x कट जाएगा. हाँ भाई रजत बोलो.
सर मैं डिस्कनेक्ट हो गया था, आपने 2 मिनट पहले क्या बताया अभी?
मेरे को भी नहीं मालूम है 2 मिनट पहले क्या बताया. रुक जा, मैं रिपीट करूंगा ना अपने आप को. डिस्कनेक्ट हो गया तो अब रिकॉर्डिंग में कैचअप करना, नहीं तो मैं उसको अभी फिर से बोल रहा हूँ. सो you remember this formula, this thing, y2 minus y1 upon x2 minus x1, y2 minus y1 upon x2 minus x1, यही तो है ना dy by dx. तो मेरे को यहाँ पे क्या दिखाई दे रहा है, ये क्या चीज है जो ब्लैक में लिखा है. Right? I have measured the displacement of the particle at time in a time interval dt. पहला पोजीशन वेक्टर टाइम t पे मेजर किया, दूसरा पोजीशन वेक्टर टाइम t plus dt पे मेजर किया, and since dt is the smallest possible interval of time, it is guaranteed that the displacement between these two intervals of time is the smallest possible displacement. इससे ज्यादा डिटेल में मैं मोशन की बात नहीं कर सकता. राइट? हाँ, exactly. It has two moments in time. Yes, exactly. Very good. It has two moments in time, t and t plus dt. Right? Therefore, what is the definition of velocity? The definition of velocity is er. This is what we mean by instantaneous velocity. So if you take the position vector as a function of time, and if you differentiate it with respect to time, that will give you the instantaneous velocity. Right? And this is the reason why I had to teach you calculus, and this is the reason why I had to teach you vectors even before starting with physics, because the 8th definition in physics requires the application of both. I'll show you an example. Yes, absolutely. Yes. मैं दिखा रहा हूँ. If the position vector as a function of time is t cube I cap plus t square j cap plus t k cap, then will you agree with me? Okay, you have to just answer yes or no. Will you agree with me that if I give you any value of time, you will be able to tell me the position of the particle? Will you agree with me that if I give you any value of time, you will be able to tell me the position of the particle? Yes, right? Now look at this. Then, so if the position vector is this, then the velocity vector as a function of time is equal to dr by dt, which is equal to d by dt of t cube I cap plus d by dt of t square j cap plus d by dt of t k cap. Please notice that I am not disturbing ijk. Okay, ijk are unit vectors which are constants. Right. So they are not to be disturbed in the process of differentiation. They maintain their positions. So the velocity vector that I get as a function of time will be equal to 3t square I cap plus 2t j cap plus k cap. तो याद है ना सबको डिफरेंशिएशन, ये छोटा वाला डिफरेंशिएशन टी क्यूब और टी स्क्वायर, मैंने बोला था ना फिजिक्स में इससे ज्यादा यूज नहीं होएगा। अभी आया समझ में मैंने क्या बोलने की कोशिश कर रहा हूं? अगर हमें पोजीशन वेक्टर एज ए फंक्शन ऑफ टाइम पता है तो हम उसको सिंपल डिफरेंशिएशन करेंगे। बस ये ध्यान रखेंगे कि आई कैप वाला जो कोएफिशिएंट है, जो कंपोनेंट है, वो अलग से डिफरेंशिएट होएगा, जे कैप वाला अलग से होएगा, के कैप वाला अलग से होएगा। और जब हम तीनों को डिफरेंशिएट कर देंगे एज ए फंक्शन ऑफ टाइम, तो हमको जो भी आंसर आ रहा है that will be the instantaneous velocity. Now look at the green box that I have drawn. Okay, look at the green box that I have drawn, and again answer the question in yes or no. Given any value of time, if I give you any value of time, can you tell me the velocity vector of the particle? Given any value of time, if I give you any value of time, can you tell me the velocity vector of the particle? Yes, of course you can. All you have to do is put in the value of t into the expression that we have got in the green box, right? तो अगर मैं पूछूं कि t is equal to 2 seconds पे क्या velocity है particle की, तो v is equal to 12 I cap plus 4 j cap plus k cap meters per second. And have you told me the velocity at a moment in time? Have you told me the velocity at a moment in time? Yes, you have told me the velocity at t is equal to 2 seconds. Therefore, we are talking about the instantaneous velocity. Therefore, we are talking about the instantaneous velocity. We are talking about the velocity of the particle. It is a vector, right? It is I cap, j cap, k cap. It is a vector. इसका आप magnitude निकाल सकते हैं, इसका आप direction निकाल सकते हैं, और ये vector is defined at t is equal to 2. At the instant t is equal to 2, the velocity vector is 12 I cap plus 4 j cap plus k cap meters per second. So the instantaneous velocity vector is nothing but the differentiation of the position vector with respect to time, right? A couple of more things that I want to clarify before we move ahead. For that, I'll try to make a more accurate diagram. हाँ भाई आप कुछ बोलो।
सर एक डाउट है, प्रीवियस स्लाइड लगाओ ना।
प्रीवियस स्लाइड कौन सा था? हाँ बोलो। म्यूट हो गया क्या? एक मिनट, अब म्यूट मत होना भाई।
हाँ सर, सर मुझे वो समझ नहीं आया, हाउ vt इज इक्वल टू dr/dt।
ये समझ में आया जो ऊपर लिखा है dy/dx?
हाँ सर।
dy/dx ही तो किया मैंने, और क्या किया है मैंने? देख ध्यान से देख, उधर पे ध्यान से देखना। इधर position vector at time t plus dt minus position vector at time t divided by t plus dt minus t. So this thing that I have written is exactly the same as this thing, ये ऊपर वाला part.
ओके सर, समझ आ गया।
है ना, मैथमेटिकली बिल्कुल सेम है ना दोनों। और अगर मैथमेटिकली सेम है इसका मतलब कि जो मीनिंग होना चाहिए वो भी सेम होना चाहिए। ठीक है।
ओके सर।
हाँ भाई, तो मैं थोड़ा सा और एक्यूरेट डायग्राम बना रहा हूँ, कोशिश कर रहा हूँ। ओह हाँ, ये बहुत अच्छा। अगेन, so did I take two instances of time? Yes, I took two instances of time. But those two instants of time were separated by what? Two instants of time were separated by what? dt. Right? Dt is the smallest possible interval of time. Smallest possible interval of time. And since it is the smallest possible interval of time, therefore you really cannot measure it. Right? I mean, you cannot go and say, अगर मैंने बोला कि t is equal to 2 सेकेंड की बात करते हैं और t is equal to 2 plus dt सेकेंड की बात करते हैं, आप नहीं कर पाओ, कोई मतलब नहीं है। It is better to say that we are talking about t is equal to 2 seconds. So although the instantaneous velocity is defined between time t and t plus dt, we will consider the instantaneous velocity to be the velocity of the particle at time t. So this is the displacement of the particle, and therefore this is the instantaneous velocity of the particle. What is the relationship between the black line, the black vector, and the green line? What is the relationship between the black vector and the green line? It is the tangent. So the velocity vector is always tangential to the path of the particle, right? And it is a vector quantity, of course, and the symbol we have already discussed, P, and the units are length over time. Right, so this is the instantaneous velocity vector. मैं एक और डायग्राम बना रहा हूं. Particle is following a path like this. This is the position vector at time t. Then this will be the velocity vector at time t. Right? Velocity vector will always be tangential to the path of the particle. This is the position vector at another time t dash. And this is the velocity vector at that time t dash. To find the velocity vector, all you have to do is differentiate the position vector with respect to time. हाँ, हो गया. Tangential because it is the smallest part of the curve. ना. So it is जब आप उसको extend करोगे, then it will become a tangent. Okay. So the next is average acceleration. Right now, I know that today I'm sort of loading you with a lot of information, and this is the reason why we took so much time and care to deal with calculus and vectors, so that you will be understanding what I am speaking now. तो हाँ, हमेशा डिफरेंशिएट करना पड़ेगा. तो lot of information I have piled on to you today. Okay, and I expect that when I send the slides, you will go through the slides again, you will go through the notes again. This requires a lot of reading again and again, right, to digest the material. What is the meaning of the position vector as a function of time? You have to understand this. Then you have to understand the fact that we are measuring two position vectors at two points in time which are separated by dt. Therefore, for us, practically, it is just one moment in time, right? And you have to understand the fact that the expression for the velocity vector that we arrive at is very similar to, or is actually the same as, the expression for the definition of differentiation that we had discussed before, and therefore we arrive at the conclusion that velocity vector is equal to dr by dt. This is absolutely different from what you have studied in class 10, right? So this requires a lot of effort for you to digest the information. And I'm going to pile on some more information now. So this thing called acceleration, okay, is something very weird. So velocity is something which, yeah, so you have to differentiate RT to get VT, yes. हाँ, ultimately जो है यही आएगा, but अभी ये जो मैं डिस्कस कर रहा हूँ ये कुछ और चीज. हाँ, वो इंस्टेंटेनियस एक्सेलरेशन है. अभी हम एवरेज एक्सेलरेशन की बात कर रहे हैं. average acceleration is a very weird object. It is weird object because as far as velocity is concerned, you can sort of visualize in your head. Velocity ज़्यादा है तो क्या है, velocity कम है तो क्या है. But acceleration is something which is very difficult to visualize because at the end, what can we see? Well, I can see the location of the particle and I can see how the location of the particle is changing, right? This is direct visual cues that we get and we can process. For example, and you should never try this, please. For example, when you are crossing a road, okay? So when you are crossing a road and you see a vehicle approaching from one side, your brain, which is a wonderful, wonderful machine, we'll talk about it later, your brain will automatically start to measure position vectors. Of course, आपको पता नहीं चलेगा कि आप position vector measure कर रहे हो, but the brain will start to measure position vectors and it will start to interpret the change in position vectors and your brain will predict the speed of the vehicle which is approaching, right? It will not be a numerical prediction, of course. नहीं तो फिर radar gun की जरूरत ही नहीं होती. ऐसा नहीं है कि आप you are looking at a vehicle on the road, हाँ नहीं ये तो 101 km/h पे चल रहा है. But your brain is in a very raw manner processing the speed of the approaching vehicle, and then your brain tells you, it makes a comparison कि भाई जो approaching vehicle है वो कितने टाइम में मेरे पास आ जाएगी और कितना टाइम लगेगा मेरे को रोड क्रॉस करने में, right? So your brain immediately does a comparative analysis, right? And if you have crossed the road, then you will know that ultimately the brain is successful in telling you whether the vehicle will be intersecting your path or not. If your brain decides that the vehicle will intersect your path, then you stop, you don't cross the road. And if your brain decides that the vehicle will not intersect your path, then you are given a go-ahead and you cross the path. So position and velocity are something which we have been seeing since our arrival in this world, and we are very comfortable with it. But acceleration is something that we cannot see, that we cannot process. Acceleration is something that you can feel when a train is starting or when a train is stopping. Then you feel this force pushing you or stopping you. That is the feeling of acceleration that you can have. But visual cues on acceleration we don't get to see, right? So therefore we must rely on the mathematical definition of acceleration. And the mathematical definition of average acceleration is final velocity, so the instantaneous velocity, minus initial velocity divided by the interval of time in which this change took place. Okay, so we have Vi comma Vf is the initial and final instantaneous velocity. Right? Symbol I have already showed you. It is a vector quantity and its units are meter per second, which can also be written as meter per second square. Right? So the units of acceleration are meter per second per second. The way that you can measure this acceleration is when you are sitting in that car, moving along the straight line, and you are looking at the odometer of the car, speedometer of the car, and you actually take a measurement of the speedometer of the car as a function of time. So you look at the speedometer of the car and you say, अच्छा 2 meters per second, E is equal to 0 पे velocity है, 4 meter per second, T is equal to 1 पे velocity है, 6 meter per second, T is equal to 2 पे velocity है. तो इसका मतलब कि 2 meter per second से velocity हर second बढ़ जा रही है. Therefore, the acceleration is 2 meter per second per second. Here, I would advise you not to. No. Average acceleration is not the same as instantaneous acceleration, even though the formula looks the same. No. If we differentiate VT, we'll get instantaneous acceleration. Uniform velocity है, इसका मतलब VF is equal to VI है. तो सेम वेक्टर्स को आप सबट्रैक्ट करोगे तो 0 आएगा, एवरेज एक्सेलरेशन 0 हो जाएगा. Okay, so let me give you a question. Particle moves with 20 meters per second velocity towards north. After 20 seconds, it moves with velocity 20 meters per second west. Find average acceleration. नहीं, अगर मैंने वेस्ट और ईस्ट यूज किया है तो आंसर भी वेस्ट और ईस्ट में आना चाहिए. मैग्नीट्यूड और वेक्टर, इसका क्या मतलब होता है बे? मैग्नीट्यूड और वेक्टर हाँ, पार्थ ने सही बताया. मेरे को कैप जे कैप मैंने चाहिए आंसर में तो. Northwest. Are you sure? Yes. Yeah. So for all those of you who are answering 0, you are wrong. All I do is north, east, and for my convenience, I cap, J cap. What is the initial velocity vector? Please don't rely on your instincts. Your instincts will not work. 20 meters per second towards north plus 20 J cap. Final velocity is 20 meters per second west minus 20 I cap. Right? Average acceleration is equal to Vf minus Vi minus 20 minus 20 minus 20 I cap minus 20 J cap divided by 20, which is equal to minus I cap minus J cap. So the acceleration vector, average acceleration vector, minus I cap minus J cap meter per second square. And I can actually make this vector, minus I cap minus J cap is here, the third quadrant. And its magnitude is √2. इसीलिए तो सिखाया था सब. माइनस आई कैप माइनस जे कैप का मैग्नीट्यूड निकालो, डायरेक्शन निकालो. ये तो हम कर चुके हैं. इसका magnitude is √2 and what is the direction? Yes, it is southwest. Very, very weird. Very, very weird. The average acceleration of this particle is √2 meter per second square in the southwest direction. You could never have guessed this, right? Southwest is, yes, it sounds unbelievable. Yes, it does. Yes. But this will be the acceleration of the point. हाँ, क्या कंफ्यूज है भाई चिराग? इसमें क्या कंफ्यूजन है? क्या कंफ्यूजन है? Vi is equal to 20 J cap. Vf is equal to minus 20 I cap. इसमें कोई कंफ्यूजन है? अच्छा. Vf minus Vi -20 I कैप -20 J कैप। इसमें कोई कंफ्यूजन है? डिवाइड